Hello scholars, welcome Mr. Hinkle, and I am excited to talk about the basic unit of landscape within a river system, the drainage basin. So this is what we're getting into, defining drainage basins, looking at their components, and discussing attributes of stream flow and river systems. So, as mentioned, a drainage basin is the basic unit of the landscape when thinking about rivers or river systems. Often called a watershed, also called a catchment. And it is basically all of the land that drains to a certain point. Let's say, here's the ocean. This is looking at this model I'm creating as if you were in an airplane. And here's a big river that goes way up, covering a lot of land. And this river has smaller rivers, smaller streams that flow into it. Well, when it rains, all of the water that runs over land and then collects into these rivers and drains to this certain point is the watershed. Now, watersheds are located next to each other. Let's put another one over here, a little bit smaller. And we could say, here is our next watershed. So we've got watershed 1, watershed 2, and the location that borders the two of them is a drainage divide. Drainage divides separate one watershed from another, and they are usually topographic high points or ridges. Great, so we've got our basic landscape unit. That's awesome. Let's talk about what's within a drainage basin. So the source, or where the river starts, is going to be up in the mountains, where rain gathers and it collects. We call this, again, the source or the headwaters, where groundwater intersects with surface water is known as a spring. So that's the groundwater, surface water intersection. Going down the list, we have tributaries. So if, from our model earlier, if this river in the middle is our main channel, all of the streams that connect are called tributaries, and where they meet is a confluence. The bottom portion, or where all of the watershed drains to, is known as the mouth of the drainage basin. So we've got the watershed, the basic landscape unit, and its varying components that make it up. These come in different sizes. We've got large, global, continental drainage basins. Here is the Mississippi River drainage basin. Here is the Amazon drainage basin. And so this is the continental divide in the United States, in the Rockies. On one side, all the water flows east. On the other side, all the water flows west. Now, you can have drainage basins and smaller drainage basins within it. So you can have a large catchment, and then you could even say this is a smaller catchment, a local drainage basin. Important to think about everything we study in terms of time and space. The global distribution has major drainage basins based on which oceans that they drain to, but then within each of these global drainage basins, you have smaller drainage basins where you can really focus in on very specific river systems. What I've drawn here is known as a dendritic drainage pattern, probably the most common type that there is, but we have other types: rectangular, trellis, radial, these occur around volcanoes, deranged. Essentially, the local geology and the characteristics of rock type, elevation slope, all of these other features are going to determine what type of drainage pattern that you would experience. But the majority of large mountainous systems that are carved by water are experiencing or exhibiting dendritic drainage patterns. So we've got the landscape unit. Awesome. The drainage basin. Well, streams flow inside of these drainage basins, and the water that's moving within the rivers is actually called streamflow. I love it when things work out so directly. It's like, what do you call the flow of water inside of a stream? Streamflow. And we could say certain rivers flow all year long. They're known as perennial. Other rivers only flow when it rains, and these are called ephemeral. You can imagine in an area with a climate that is relatively wet, the rivers are always flowing. In a climate that's very dry, the rivers are only going to flow when it's raining. So you have tropical rainforests versus desert environments. Earth surface processes are distributed unequally across the globe, and climate plays a huge role in the geology and the Earth surface processes that we see located all across our Earth. Examples of a perennial stream. So here we can see water is in this channel. It's a little bit low, but there's a base flow that goes all year long. Here is a dry wash. So when it rains, it'll get caught up here in its headwaters. It will flow down this channel. Stream flow only occurs when the rain is present. Okay, so let's continue to catalog and identify components of the river system. So up in the headwaters, let's see, I think I want to redo this one for you. Within a drainage basin, we have 3 distinct zones. Where it's mountainous, and the rivers are doing a lot of erosion. Tributary, 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 confluence, confluence. This is actually called the zone of erosion. And then rivers will travel, this is a meandering stream, across flatter landscapes, and this is the zone of transportation. And then when the rivers can no longer transport the sediment that they carry, it starts to deposit in alluvial fans or deltas, giving us the zone of deposition. If we were to look at this river system, you would say it's a lot steeper up in its headwaters, less steep in the zone of transportation, and then pretty much flat where the zone of deposition occurs. And so we could put this into what's called a longitudinal profile, where the gradient or slope is higher at the source and lower at the mouth. This is important because gradient is going to greatly influence channel morphology and also be a determining factor of the specific fluvial processes that are occurring in that place, certain position of the river system. So let's talk about river systems. Rivers have different forms and processes in each zone, differentiated by the longitudinal profile, which indicates what the gradient is. I think I mentioned this, but the attributes of channel form and process give it a very specific channel morphology that can be identified and understood so that we can know how water is shaping Earth's surface in order to utilize this essential natural resource for the greater good of all. So in conclusion, rivers are characterized by the drainage basin, the basic unit of landscape. Within a drainage basin, you have specific zones based on processes as determined by the gradients we can see on the longitudinal profile, and those in turn are going to dictate or control channel morphology and fluvial processes. Thank you so much. This is our intro, this is our discussion on drainage basins.